Ladies and gentlemen, today we will solve Analysis and Approaches Higher Level Paper 3. This is from May 2025, Time Zone 3. And before we begin, I would like to tell you that Paper 3 is a lot different from Paper 1 and Paper 2. It doesn't demand you to solve a lot of short, isolated math problems. It's a connected research sort of a question. So this is where IB really tests the HL students. Before we begin, just pause the video and make sure you read these instructions. So, in short, it says that in order to gain full marks, you have to show all your work, detailed working, supported by answers, explanations, and not just relying entirely on the use of GDC. Even if you use your graphing display calculators, you can give key features of your graph and justify your answers, right? Okay, so question one. This is a 27 mark question. This question asks you to explore self-composite linear functions of the form f of x is mx plus c for varying values of m. A function composed with itself is called a self-composite function. For example, they're saying for the function f, the function composition with itself is given as f(x) or f of x. Like it means the same thing, it's just a notation. And now they're saying that let f to the power n denote the nth composition of f with itself. So it's all the way like f dot 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 f and x. All right. Hence, for example, f squared can be written as f of fx and f cubed will be ffx. Consider the linear function f of x mx plus c, where x is real number and m and c are real number as well. Part A. Show that the first part, I need to show the expression for f to the power 2, which is f squared or f of fx. So in order to find f squared x, you can write it like f bracket f of x and put the function inside its domain, mx plus c and plus c. So this will be m squared x plus mc plus c, and I can write it m squared x plus, if you factor out the c, I would like to write it like that. If you write m plus 1 or 1 plus m, it doesn't matter. 1 plus m. And that's it. That is my A1. Okay, now in the next part, I need to show this expression for f cubed. Well, I can maybe do it here. I'm sorry, I'm solving it on the question paper. So otherwise, in the actual exam, you'll be given an answer booklet where you will write your answers. So f cube x will be written as, you can write it like, let's say, f and f squared of x. All right. So you are putting the squared function inside itself. This will look like m times m squared x plus c times 1 plus m. And don't forget this plus c as well. All right, so m cube x plus m c plus m squared c and plus c. So finally, I can write it m cube x. If I factor out c, I can see they are writing it as like 1 plus m and plus m squared, right? Okay, so I managed my solution in this tiny place. All right, part B1. Write down an expression for f to the power 4x. Now, the question doesn't say prove or show or find. It just says that write down. It means you have to observe a pattern. So what is that pattern? If you look at f cubed, it has a f cube x. If you look at f squared, it has a m squared x. And then uh, by this, I think you know it already that I will start as m to the power 4x. And you write c, since the f square ends at m, the f cube ends at m squared. So the f to the power 4x will end at m cube, 1 plus m squared and m cube. There we go. That is the expression for, and now they're saying part B2, suggest a similar expression for f to the power nx. So let's go. We can just follow the pattern. M to the power nx plus c, and this will be 1 plus m squared plus dot 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 and m to the power n minus 1. I hope you get the idea that since it ends at 1 less than the power of the function, so that will be m to the power n minus 1. Now, part B3 says, this is part B1 and this is part B2. And now I will do part B3. They're saying by using the expression from part B2 or otherwise, find an expression in terms of n for f to the power nx when m equals to 1. I mean, you can use your expression or maybe otherwise. Otherwise means like you can follow the pattern, right? So, okay, let's just use the expression first. So if m is 1, my function to the power nx will look like, first of all, m is 1, so this becomes x plus c times all these ones like 1 plus 1 plus 1 plus dot 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 and 1. Okay, so this, if you don't know, the nth sum is always like n. This sum can be written as n. So this will be x plus cn. The otherwise idea, if you want to look at that, like how does that work? So come on, let's just take a look at this. Like f of x will look like x plus c. The f squared x will look like x plus 2c. And f cube x will look like, I'm just using these expression and plugging in m equals to 1. So x plus 3c. So dot 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 all the way, if you look at f of nx, that will look like x plus NC, right? So CN, I wrote it like, I think it's better if you like it like NC. Okay, there we go. All right, let's move on to the next part C. For m not equal to 1, use mathematical induction to prove that this result holds. Oh, if you have observed this, look at this. They have written this thing as a sum of a geometric series, like, and you know, like as a geometric sequence, it's increasing. The common ratio is m, and the nth sum, right? Okay, so how do you begin with the mathematical induction? You always give the base case, right? So what's the base case? I mean, you can write it first, like let the proposition be true, right? For f of n, this expression, like, you know, like the first lines, you need to write them first. So the base case is like, let's put n equals to 1 because n can be 1, right? And f of x will turn out to be mx plus c times, this will be 1 minus m over, let's say, 1 minus m, because n is 1. So this goes away. So I can write it mx plus c, so which is true. All right, so my base case is proved. Then what's the inductive step? Inductive step. So here you will say, let f k x equals m to the power k x plus c times 1 minus m to the power k over 1 minus m holds. And now we wish to show, oh, I'm running out of space. Let's prove that like f of k plus 1 then b uh, can be written as f of k x, right? So it means now I need to apply this thing inside the linear function. That will be m times this whole thing, like m of k x plus c 1 minus m to the power k over 1 minus m. And that's it. So this will turn out to be m of k plus 1 x plus mc, and this whole thing 1 minus m to the power k over 1 minus m. Okay, so, oh, I've forgotten the C. Sorry, my bad. There was a C here as well, right? Don't forget that. Okay, so it just came to my mind that something seems missing, right? Okay, this and plus, if I factor out the C, I will get M times 1 minus MK, 1 minus M and plus a 1. Okay, so let's hope I finish it within this space. Plus c. If I open the bracket, this will become m minus m to the power k plus 1 and make it a single denominator, 1 minus m over 1 minus m. And this cancels this. Okay. So finally, I think I've got it. I can write it like c times 1 minus m to the power k plus 1 over 1 minus m. So you will say, hence, p, or you can say f of k implies f of k plus 1. So by the principle of mathematical induction, for all values of n, fn is true. Right? So I have just skipped some lines, but I hope so that since the exam is very near and I believe that you have some practice and some knowledge of mathematical induction. So I just went into the working part, but do choose the right words because they matter a lot in the IB maths, right? Okay, so now we move on to the next bit. Consider f of nx equals to this, where m is within minus 1 and 1. Okay, so m is within minus 1 and 1. So think about it. This means that m is a proper fraction. Part D, as n approaches infinity, the family of graph y is equal to f of nx approaches the graph of the straight line L. Determine the equation of L giving your answer in the form in terms of C and M. All right, so okay. So if n approaches infinity, now you can say that m to the power n will approach 0. What is the reason? Why did I say that it approaches 0? Since m is a proper fraction, when you raise higher powers to a proper fraction, it eventually becomes too tiny, too small, becomes negligible. So you say it approaches 0, right? So my expression will now look like f of, they're saying a straight line L. So let's just say, since n approaches infinity, this approaches a straight line L. This will be, so this becomes a 0 plus c and 1 over 1 minus m. So I can write it like c over 1 minus m. Well, that can be a horizontal line, straight line, right? Okay. So next part, f of nx equals to this, where m is a negative 1. Okay. Part E1, show that f of n x is this when n is odd and when n is even. Okay, that looks simple. So part E1, for that, if first of all m is a minus 1 and let's say yeah, n is odd. Okay, so this will look like f of nx will be minus 1 to the power of an odd number plus c and 1 minus 1 to the power of n over 1 minus a minus 1. So we know that a negative 1's odd power is going to be negative. So this will become negative x plus c times, this turns out to be, since it's a negative 1, so 2 over a 2. And so my answer will be minus x plus c. And for the next parts, again, m is a negative 1, but n is even, right? So f of nx will now look like minus 1 to the power of nx plus c, and this whole thing minus 1 and n over 1 minus a minus 1. And this will become, since it's an even number, so now negative 1's even power will become a positive. So that is this, and c will be, oh, this time it's positive, so this whole thing becomes a 0. So I will end up with just x. And that's it for the first question. Question 2. Maximum mark 28. This question asks you to consider open-topped boxes formed by cutting square corners from an A by B sheet of cardboard and folding the sides. In particular, you were asked to investigate conditions for which the maximum volume of the box is an integer. A rectangular sheet of cardboard measures A centimeter by B centimeter, where A is less than B. A square of side length x centimeter is cut from each corner, and the resulting sheet of the cardboard is then folded to form an open-topped box with a rectangular base. This is shown in the following diagram. So they've taken a rectangle, A by B, A is width, B is length, subtracted 4 corners, and they are squares, folded along the lines and formed a cuboid. The volume V of the box is given by this, and this is a cubic expression, L into W into H, where X is within 0 and A over 2. Part A. Write down the value of V when X is 0. So this will make the volume 0. And A2, if you sub in, it's a 1 mark question, A over 2. A minus 2 times A over 2 is a minus A. So this will end up a 0 as well. Part B, show that volume is given by this expression. So I've got this expression. Let's expand this. So V is going to be X AB minus 2AX minus 2BX plus 4X squared. So when you're trying to show something, keep an eye on the result you're trying to get. So let's rewrite it 4X squared and factor out the 2. Write it A plus B and write X in the end. I'm just trying to copy the thing they're trying to show. Plus AB. And now expand again 4X cubed minus 2A plus B X squared and plus AB X. This is a result. Let's take a look at the part C. Show that the only solution of dv over dx equals 0 are x this. So I need to differentiate the expression I got in part B. This will be dv over dx equals to 12x squared minus, let's write it like 4a plus b x and plus a b. And now put it equal to 0. This is a quadratic expression. Let's go with the quadratic formula. So minus b plus minus b squared, which is going to be 16, a plus b whole squared, minus 4 times 12 times ab. And divide the whole thing by 2a. So let's just do some simplification. 4 times a plus b plus minus. Well, I can see there's a 16 and this will be 48. So if I pull out the 16, that will become 4 outside the third. I hope you get it. What did I just do? So this will be a plus b whole squared. And minus this will be 3ab now. And divide the whole thing by a 24. So factor out the 4, write a plus b, a plus minus, root of, let's expand the expression inside the third, a squared plus 2ab and plus b squared minus 3ab. Sorry about the space. I'm just solving it on the question paper. But in the actual exam, you will be given an answer booklet to write on. So let's close the bracket. And this is 24. So now 4 times 6 is a 24. So I'll be left with a plus b plus minus root of a squared minus ab and plus b squared and divide by 6. Hence shown. Right? Okay, let's move on with the next parts. They're saying in parts D and E, these, the following 3 results are given. So X is either the positive, in the middle root, the negative is the solution that I got from the previous part, right? And this thing is positive, right? Okay. So they are saying let X sub M equals to A plus B minus square root of a square minus ab plus b square divides 6. They're saying part D, use the double derivative of v to show that there is a local maximum of v at x equals to xm. So for the local max, I need to redifferentiate my first derivative So for part D, I'm going to differentiate it again, d squared v over dx squared. I'm keeping an eye on my first derivative, which will be 24x minus 4 times a plus b, right? So let's substitute this expression. This will be 24. Let's plug in the expression a plus b minus the root of a squared minus ab plus b squared and divided by 6 and minus a 4 times a plus b. So this becomes 6 4 times 24. So I get 4 times a plus b minus 4 times root of a squared minus ab plus b squared and minus a 4 times a plus b. So these cancels and I'm left with a negative 4 root of a squared minus ab plus b squared. Now they were asking that show that there's a local maximum. Now, in order to make this a local maximum, I need to show that my double derivative's value is less than 0. But how do you prove it? So first, you can say since root of a squared minus ab plus b squared is positive, you can see that it's given over there in the condition. Therefore, the negative 4 times this expression a squared minus ab plus b squared will be less than 0. And since d squared v over dx squared is less than 0 at xm, there is a local max, right? Okay, let's move on to part E. Use your answer to parts A and D to explain why xm x sub m will give the maximum volume V of the box. Okay, now that's an interesting question. It's asking for justification. So in part A, we figured out that volume becomes 0 at, you can say, just imagine it like this. So volume becomes 0 at 0, and then at a over 2, it became a 0 again. So within this, there is a maximum. And remember, it's a cubic function. So cubic function will definitely have another value which will be a minimum, and that is a maximum. So you can write it in your words like within this closed interval, a cubic expression will give a maximum, and that will be like an absolute maximum, or you can say in the words of IB, a global maximum, right? So hence, since volume is 0 over there, 0 over here, so there will definitely fall a maximum within a and a over, sorry, 0 and a over 2. So you can rewind and listen to this again and write this justification. And okay, let's move on to the next part. In parts F to H, consider a method of generating sets of positive integer values for xm and hence volume V sub m. Consider the case where A is this, 2st minus s squared, and b is t squared minus s squared, and s and t are positive integers. Part F. Given that a is less than b, show that t is greater than 2s. Okay, so in order to do that, I can put 2st minus s squared less than t squared minus s squared. So you can add s squared to both sides. This will get rid of the s squared. So you have 2st less than t squared. Now divide by t on both sides. These are integers, remember. So 2s will be less than t, or you can say t is more than 2s. This is shown. So it means if these are positive integers, whatever you take as t, a double of that, double of s is going to be smaller than t, right? Or you can say whatever you take for s, double of that is going to be smaller than t, right? Okay, it is given that square root of a squared minus ab plus b squared, the expression which we already spotted, is this. You are not required to show this result. All right, part G. By substituting for each of a, b, and this in terms of s and t, show that x sub m is this. Okay, now we need to sub this, all of this. Okay, maybe I can solve it over here, right? Okay, so let's see if I can manage it over there. Uh, I'm going to do part G over here. Okay, so x sub m will be, let's sub in the value of a, which is a 2st minus s squared. And now I need to add a b squared, which is a b, which is a t squared minus s squared. And now there is a minus of this, and its value is already given. So let's bring in minus s squared plus st and minus t squared. So, I mean, if you find it confusing, I'm sorry about cramming my solution in a tiny corner, but you can just pause the video and try to substitute these values. I mean, this one, and this one in this expression and see, you'll get the same thing. So let's get rid of these t squareds, and I'm getting 3st. Oh, my bad. This was a 6. Okay. I just saw that. Okay. Minus 3s squared divide 6. So let's factorize 3s. This will be t minus s divide 6. So 3 double and s times t minus s divide 2. So that is my result for part G. All right. Now part H1. So it says, given that a, b are positive integers, use v sub m equals to x sub m, a minus 2x sub m, b minus 2x sub m. So it's the same volume expression, but this time they have changed it with the x sub m, which was, the local maximum value, to explain why s being even implies that vm is an integer. Okay, so they are saying for H1 that if S is even, okay, then why VM is an integer. So let's take a look at this. If S is even, then X sub M equals to, what's the expression we found? That is going to be S times T minus S divide 2. So we clearly know that will be even since there is a factor of 2, right? So s can be any even number, so even number times anything, and even if you half it. So since you can say that a and b belong to positive integers, this implies that in the volume expression, a minus 2xm and b minus 2xm. Now think about it. Positive integers minus 2 times some even number, they will belong to z, right? So that's it. That's a positive expression as well. Therefore, you can say that v sub m belong to integers, right? So this is what the question was asking about. That is just a 2-mark reasoning question. Let's move on to part 2, H2. And I am running out of space. Oh boy. Okay. So they are saying state another condition on S and A, corresponding condition on T. Okay, that implies that X sub M and V sub M are integers. All right, so we need another condition now. We know that, let's say, if S is odd, all right? Then in order to make this X sub M an integer, you can say that we need to make T minus S should be even, right? And this will only happen if t is odd, because the difference of two odd numbers is also an even number, right? So that is a valid condition. Let's say x is odd and t is odd. And since you get the idea, this becomes, and then x sub m will become an integer, right? If that is an integer, then you know that x minus uh, like this a minus 2xm and b minus 2xm belong to integer, and hence v sub m will be an integer, right? Okay, so now, oh boy, where do I solve the last part now? H3. Hence or otherwise find an integer value of x sub m and find the corresponding integer value of v sub m. So this can be done like I just need to suppose some values. So let's begin with an with a unit value. So if s is, let's say, 1, and I can make t as an odd number as well, okay? Because that definitely proves that we will be an integer. Okay, so s is 1, t is odd. So now what happens? I need to check what does a becomes. So a will become, okay, do I need a? Yeah, I do need a, okay? So a will turn out to be, let's use this expression. So 2 times 1 and 3, that's a 6 minus 1, that's a 5, okay? And b will become 3 squared and 9 minus a 1, that's 8. Okay, so these are the values I'm getting. So this way, I'm really sorry, kids, but just keep an eye on this, like what I'm trying to do. If you find anything difficult, or pause it and try to come back and connect with it, right? Okay, so what happens to x sub m? This will become, let's say 1, 3 minus 2, that's a 2. Okay? So 2 times 1 is a 2. That will become a 1. Okay? So now I've got all my values. So let's put them in the volume expression, this one over here. So v sub m will become 1 times 5 minus a 2 and 8 minus a 2. So that's a 3, and this is a 6, and this is 18. I mean, this is one possible value of the volume, but you can get more values by supposing different values, right? And that's it. That was the last question. And if you have made this far, I would like to congratulate you. Keep following for more useful resources. This is Global Math Mentor. Over and out.